Hello.
Hi.
Yeah. Okay. So good morning. Okay. Okay. So basically today I already write the code for your project, and today I will explain one by one so that you can easily understand how it will be work. Okay. So basically you want to learn about that how we can easily create the time series of NDWI and also make the land cover for time series. Mainly it will be start from year of 2015 to year of 2005 to 2015.
Yes.
Okay. So let's go. Just I simply share my screen.
Yeah. Okay.
Can you see my screen now?
Yes, sir. It is getting shared now. Just one second.
Okay. Okay. So now you can see my screen, yeah?
Yes, sir.
Okay. So in this time, here I first of all we have to collect the image collection from year of 2005 to 2015. Okay. So for that, you can see here, I just simply take all of those image collection. First of year of 2005, then 2006, then 2007, then 2008, then 2009, 2010, 2011, 2012, then 2013, 2014, and 2015. Okay, we collect these satellite images. In this time, we are combine Landsat 5, Landsat 7, and Landsat 8 image collection combined. After that, we just calculated that NWI, mainly year of 2015, then 14, then 13, then okay. So in this time, I add all of those things one by one. I explain the code and write the other part. So first of all, here you can see this is your study area which you send me, mainly your Pune study area. This study area I simply imported in Google Earth Engine platform. Okay.
Also, if I have another shapefile for another district, I can simply import it to Google Earth.
Yes. For that, how we can easily import? For that, simply go to the asset tab and then click on the shape file. Okay. And further go to your source file from your local storage and select mainly you have to select the four file. So for that, it's extension 4 file. It's mainly I show you that. Suppose you can see this is your shape file. You have to select SSP, SXX, PRG, and DBF. Okay, mainly 4 file you have to select and then open it and further upload. Okay, I already uploaded. When you upload it, then you can simply see your task tab will be running. Okay, and you can get that it will be this type of right sign in here. It means that this file is successfully imported in your drive in your asset tab. Then simply click on the refresh button and find out the file name. Okay, you can see it, the file name is the Pune, and also you can see the file name is the Pune. Just simply find out the file name and click on here and then click to the import. Okay, so just I simply import and then give the name is the AOI. You can put any name as a variable. Okay, after that I simply use this function map.center object function. Basically this function help you to the center focus on your object. Okay, so basically AOI is stored your boundary shape file, and when I use here the map.center object function, it focus on the boundary shape file. Okay, directly focus, and then I just add a layer of this shape file. Okay, AOI. So just use the map.add layer function and call this shapefile variable name. So now I can visualize. You can see I just add this layer for boundary. It's my boundary area. Simply uncheck that. So I add this boundary. So this is my boundary area. Okay. When I add map.add layer function, then I can get this boundary area. So after that, here you can see here all of image is very clear. There is no cloud or haze because I already add the code for remove the cloud and haze from my satellite images, mainly Landsat 457 as well as also Landsat 8 imagery. Okay. So basically,
Sir, just one second. For Landsat 7, which years you have taken data from? Like for which year you have taken data for Landsat 7? Because Landsat 7 after 2003, there is some problem in the
yes. In this time, we are applying the another technique. This technique is that we are merge. Suppose Lancet 5, Lancet 7, and Lancet 8, we are merge together.
For for over the time period, for all the years.
All the years.
Okay, okay.
Okay, and then from here we just select our specific year. Suppose you can see, suppose this is the code for mainly it remove the cloud and haze from the satellite images, and this is the code mainly it remove the cloud and haze from the Landsat 8 images. And then I in this time I simply create my time period. Suppose my time period is that start year, suppose year of 2005, and in year suppose 2015. After that I just make a sequence, mainly 2005 to 2015. I just make a sequence or list 2005, 6, 7, 8, 9, 10 up to 2015. Just use the sequence function. Okay, and further we are just make the band. Suppose Landsat, you can see SRB1, SRB2, SRB, this is the band about the Landsat 5, and this is the band name. Okay, you can see here Landsat 5 and Landsat 7, SRB1 is the blue, but Landsat 8 is the SRB2 is the blue. Okay. So in this time we are just make also band name. So that's why in this time we are not using the band. We are just using the band name. Okay. Suppose SRB1 is the blue, SRB2 is also blue. Okay. So that's why when I use the blue, it consider all of satellite images band. It can be like 5, 7, 8, all of those band. Okay. So now in this time here you can see in this time we are just take this first of all we take this Landsat 8 image collection. It's the Landsat 8 image collection. We take basically it's a surface reflectance image collection, and we take the cloud cover less than 19%. In this time it's this benefit is that when I take the more cloudy image, then it create my more image collection. Okay, and when I apply the cloud marks function, basically you can see this is a variable map, and this variable stored the cloud marks band function. Okay, this is the cloud marks band function, this variable. Okay, and when I add this variable in here, it remove all of those cloud from my satellite images, and I consider in this time you can see year of 2013 to 2023 all of year for Landsat I take, consider and make this collection, and this collection is stored in the L8.
Okay, so first we put it as cloud cover less than 90%,
Yes.
and then we mask it to get a clearer picture.
Yes, 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 yes.
Okay.
And this is the same thing we also apply for the Landsat 5. Okay, we take the Landsat 5 image collection and took a whole period, time period, and then we are take in this time you can say I don't filter any types of cloud cover. First of all I put the filter metadata, but in this time I not use that. When I don't put any types of filter metadata, it means that it consider all of those cloud level. Okay, all of those cloud level in this consider and make this very large collection. Okay, but when I put here this function cloud marks 457, basically this function is stored the removing the cloud or haze from the satellite images. When I add that, then it will be easily remove all of those cloud, and I can get the very beautiful image in here. Okay, and also do for the same for the Landsat 7. Okay, I put the Landsat 7 image collection, and further we are put this time period, and we are selecting also put here this function of removing cloud and haze. Basically Landsat 457 is the same code for removing the cloud and haze from the satellite images, but some difference in the Landsat 8. So that's why we create the two function, one function for removing the cloud from Landsat 8 satellite imagery, and another function for removing the cloud from Landsat 457, basically 57 in this time we are using here. Okay. So now we make this collection Landsat 8, 5 and 7, and further we are just merge. You can see we are just merge Landsat 8, 5 and 7, we are just merge. Okay, and it's stored it in here. So in this time we can see how many collection I can get after merging. Here I can get total collection 2166 images. It is stored total 2166 images. Okay, very large number of image collection I get in here for Landsat 457. In this time, anyhow, I need to create this image collection annual composite. So this 2166 images, I just need to convert into annual, mainly 2005 to 2015. Total 11 years. Okay. This total 11 years, I just convert this 2166 images, just convert into 11 years. Okay, mainly year, 1 year or annual composite we create.
Okay.
So for that, in this time, we are this it stored the total this image. Just I simply use a function e.image collection from image. So
Huh.
basically, this function we are used. Suppose I have a collection, and this
Huh.
collection I want to convert into other time period. Suppose already I have a collection. This collection I have already 2166, and now this collection I need to convert into yearly, mainly total 11 years from year of 2005 to 2015. And I already defined the time period in here. You can see years. I already make the sequence by
Huh.
years. So now in this time, I just use this function image collection from image, and now I create a function. Okay, in this time, I just create this function. Here you can see this is the function, and this function mainly create the annual median composite. Okay,
Huh.
and which time period? This time period mainly 11 years, and this 11 year is stored in this variable years.
Huh.
Okay, so after creating this function I need to connect with my 11 years time period. So for that I simply call this variable, because this variable is stored at the 11 years, and use here the map function. So basically this map function help you to connect the collection with your function. This is my function which I selected in here. It's my function. This function I just connect with my collection total 11 years, this variable. So that's why I simply use the map function. Now this function is connect with my collection, annual collection. So in this time, this variable when I print, you can see when I print this variable, I can get the only for the 11 years, mainly 11 elements. So I check all of those. You can see it show the all of those images. Suppose you can see first it show about the 2005, because it I put my time period year of 2005. Then I can get the image for 2006. Then get the image for 2007 and up to 2015. And all of those images have total 7 bands. Okay, you can see blue, green, red, near infrared, short. So necessary band I simply put in here all of those images, because I already defined the Landsat band and Landsat band and band name. I already defined in here. You can see all of those band name. So that's why this time it show about the band name. Okay, but when I put here that band number B1, B2, B3, then it will be misclassified, because band number is not same for Landsat 5, and Landsat 5 and Landsat is the same, but Landsat 8 is the different. Okay, so further in this time we are just consider about the band name: blue, green, red, near infrared, short infrared, and short infrared 2. So further we are doing these things, create this collection. We are just filtering. Suppose in this time I call this annual collection. I call the annual collection. From this annual collection, I just filter. How I can filter? Where year equal to 2005. Okay, so here you can see. Suppose you can see the suppose first image. You can see year equal to 2005. Okay, so in this time, I just simply call my annual collection, because this annual collection already stored total 11 years image collection. Okay, this 11 I filter it. How I can filter? Where year equal to 2005. Okay, then it show about the image 2005. Then I set the visualization about that Landsat 5. Same for 2006. You can see I call the annual collection. I filter it. How I can filter where year equal to 2006. Then 2007, 8, 9, 10, 11, 12. All of those things the same. We take the total 11 years image, annual image composite. Okay. So now it visualize all of those images. I already add the layer. You can see Landsat 9, 10, 11. All of those things we add in here. So now this image collection we are use, and then make the NDWI as well as LULC for year of 2005 to 2015. Okay. For doing these things in this time, we are just take a variable, suppose NDWI 2015, and then call the image of 2015. I already make the image 2015, and then apply the function normalize difference function. Basically, this function computed as, suppose in this time I put it the green and near, so it computed green minus near divided by green plus near infrared band. So it's the equation of the NDWI.
So,
Okay.
sir, in this 128 row, that formula is already like put here, read by LIS, that
Yes.
NDWI
Yes.
formula is already put
Yeah,
here.
so it's a built-in function. You can see I can get the more information about this function. This function mainly computed when I put the band name. Suppose I put the band name first and second band. Suppose first is the green and second is the near infrared. I put in here. Then it computed as first minus second divided by first plus second.
So this is a default this setting for Google Earth Engine.
Yes,
Never
yes.
been tried like
It's a built-in function in Google Earth Engine. So
Okay.
when you put the normalized difference function, it automatically computed first band minus second band divided by first plus second band. So in
And
this
sir, one more thing, if I want to calculate like furthermore one step modified that NDWI, there we use green and SWIR. So can I just replace NIR with SWIR?
simply put at the SWIR. Okay.
Okay.
And you can see here, I already added all of those band in here. You can see my band name. I can see sorry, it's SWIR1. So I have to put at the SWRI1. Okay. So now it will be calculated from that SWRI1. Okay. So just I simply press all of those things.
Yeah.
Time you can see 2015, 14. Okay. We have to add the 12. So just I simply copy same line and then paste here. I simply change the variable. I put the variable suppose NDWI year of 2012 image 12 because I already defined the variable name 12. Okay. Then 11, 10, 9, 8. Okay. In this time I simply copy the same things from here and also add the NDWI for year of 2007, 2007, 2007. Okay. It also okay. No problem. Then put that 2006. Just put here the 2006. Also call the 2006 image and further put here that 2005. Also put here the 2005. Okay. So now we create all of this NWI map. So now I visualize in here. So for that we are just map.add layer and call the NWI 2015. Okay. 14. Okay. And suppose I simply copy that things. Copy. And then I want to add for 2012. So just put add and call the NWI 2012. Okay, and also put the layer name, suppose 2012. Okay, then 1110. Okay, just I paste here again. I put this 2007. Just put here the 2007. Okay, and also put here that layer name 2007. Then 2006. So put here the 2006 and also put here the 2006. Further 2005. So just put here that 2005. And also put at that 2005. Okay, so now it's created. So now click to the run and we can get all of those NWI layers. Okay.
Okay, these layers will create, NDWI layers will create once we run the function. Then these layers will come like NDWI 2005,
Yes.
2006. These will come there.
Yes.
Okay. Sir, what this NDWI value is basically the average value of 2005
Yes.
for that year, right?
Average. Yeah.
Okay.
Okay, so it loaded all of those things, all of this layer. So now further we are just export all of this layer. Suppose I exported 2005, 2006, all of this I export. And further for you can easily make the map layout in ArcMap software or QGIS software. Okay, so you can see it added all of this 2005, then 2006, 2007, 8, 9, 10, 11, 12, 13, 14, and 15. Okay, it shows all of this.
Then how do we export from Google Earth Engine?
In this tab, we export this type of map as a grayscale color. Okay, suppose in NWI, I simply export as a TIFF format. And further, we are using the ArcMap software for create the map for our research paper or presentation. we easily create the map and use it.
And then the value of NDWI for 2005 for Pune district till 2015, I will get in ArcMap only, that value which is generated after this code.
Yeah, we can also get the value from the arc map, as well as if you want you can also calculate the value in Google Earth Engine platform. Suppose you want to calculate it at 2005, what's the average value we can get. 2006, what's the average value of NWI? 2007, what is the average value? Okay, these type of things we can easily calculate it from Google Earth Engine platform also. Further, we also write the another code. Just I show you that also. Suppose we calculate the value.
Yeah, because I need these particular values for my further modeling. That is
Okay.
yeah.
So for calculating the value, suppose I take a variable. Suppose NDWI in or average value. Mean value. I take a variable, look like that, and then call this. Suppose I calculate the value for 2005, 15, and paste here, and then use a function mean. In fact, that just use a function reduce. Okay. So basically, this function calculated for statistical part. Suppose minimum, maximum, standard deviation, this type of value. When you calculate, we have to use this function, and I simply press Control and space on my keyboard. I can get all of those argument about this function. Now further, I just make a dictionary. So curly bracket start, and also curly bracket in, and now I make the keyword and key value in my dictionary. So first of all, reducer. In this time, I am to calculate it the average result. So use here ee dot reducer dot mean. Okay, it's the average. Geometry, mainly it's your boundary shapefile variable name. Boundary shapefile, mainly you can say I already defined the shapefile variable name is a AOI. So write this variable name is a AOI. Scale is the resolution. For Landsat, we put here the 30-meter resolution. And other thing not there. I simply remove that. So now simply print that variable. So simply print in this variable, mainly NWI mean value. I simply print that. So now it show you the value. What is the average value of NWI in 2015? Okay, okay, it show that. Okay, NWI mean is not function. Okay, so right. Okay, so you already calculated that mean. So that's why in this time, this image is already have the mean. So that's why in this time we not need to put any kind of mean again. In this time, we can see it show this type of problem. We can easily handle this problem. In this time, it show about that there are the lot of pixel, too many pixel in this region. In this time, we have to mention about the max pixel value. Okay, so just I simply copy the max pixel argument and further share the max pixel. I put the value suppose 1E13. So basically, these things we have to mention when you want to work with the big region. But a small region without max pixel value it will be work.
Okay. So what we have like earlier calculated, that is already a mean value of NDWI.
Yeah,
So
yeah,
we
yeah.
don't need to put the mean
Yes,
function
yes,
again.
yes, yes, yes. So basically, this map is already represented that mean
Okay.
result. So that's why again when you put that, then it will be show wrong. It now it's computing. Okay, so done. So simply click on here. Here we can get that mean NDWI value is that 0.1594. This type of value we can observe from here.
Okay, okay.
Okay. So in this time, after doing this thing, suppose in this time, suppose you want to do for the 2011 terms, just simply change the variable name. Then it calculate for this specific year mean and what is the value about the NWI mean. Okay. Suppose in this time you want to observe the what is the average. Oh, sorry, what is the maximum value. Okay. So for that you can just put here the max argument. So now let's check. Okay, so now check the value. We can get that it is the maximum NDWI value for year of 2015, 0.17. Suppose you need the minimum, just put here the MIN, mean. Or standard deviation, just put the SPD Okay, suppose SPD then we can get the standard deviation value for 2015 NDWI. This is the process about that. Okay, for calculating statistical value from a image. Okay, so now this is the process about the NDWI. Okay,
Yes, sir, just one small question. When we are merging these three Landsat, Landsat 5, 7, and 8, and when we are running this for the time series data, so it is itself like automatically taking value, like whichever is available, whichever year is available for a Landsat 5, it is taking from 5, whichever
yes,
is
yes,
available
yes,
for 8, it is
yes,
taking from.
yes, yes, yes.
It is like that.
Yeah,
Okay,
yeah, yeah.
okay, yeah. Fine. Fine.
Okay. So in this time, this is the NWI part. So in this time, we talk about the land use, land cover classification. So
Okay.
basically, for the classification, we have to put the more process, such as we have to create the first of all, we already make the image for each year. Okay. So in this time, we have to create a machine learning model and then put all of those images. Suppose 2015, 14, 10, 9, 8, 7, all of those images we are just put in here, and then further we are classified. Okay. So in this time, how many class you want to classify, and what is the class name?
Yeah.
Okay. So how many class you want to classify? Water body, build up area, or vegetation.
Yeah.
Okay, as well as also barren land. Suppose you can classify it, suppose water body as well as suppose barren land, then build up area as well as also
Crops
vegetation
also.
or agricultural land. Okay. So in this time, I will show you that how we can collect the training sample. Okay, then you are also take the training sample for all of those images. Okay, so then I can show you that for the I also need the another session, then you can easily calculate it the full project about that. So in this time I show you that how we can easily collect the training sample, and then further we are use it to make the land use land cover classification map. Suppose in this time I want to take the training sample for a year of 2015 images. Okay, so just I simply open the image, and there's a lot of way to taking the training sample. In this time, we take the training sample from the satellite images. Okay, and for that we are applying the different types of band combination, and we identify the different types of feature on this map. So in this time, this band combination called the natural color. Okay, mainly what human eye can see naturally, it show this type of color. So in this time here you can see I can get this type of things. I can easily find out, suppose it's a water body, we can easily find out it's water body, as well as also we can also get this type of green pixel also in here. Okay, you can green. Okay, so it's a vegetation. So it's a one kind of natural color, but we are also used here the different types of pen combination to get the better view of the different types of feature on the surface. Suppose one band combination called the, I simply click on here and I can easily set the different types of band combination from here. Suppose I simply set that near infrared band, then put here that red band and blue and custom stressing 98%. In this time I can get the another band combination. Okay, so you can see, simply apply that. So now it show you the other types of band combination. Mainly in this time we can get the vegetation as a red color. Water body show as a dark color or black color. You can see I can get this type of things. Water show as a black color. Okay, you can see black color. Black color. It's a water, and I can get, yeah, this type of things. You can see it's a build up. Okay, this type of white color. You can see white color. This type of white color show as a build up region in here, as well as we can get the vegetation. This type of vegetation show as a red color. Okay, so better red color have identified the better vegetation. It's a vegetation. Red color is the vegetation, and water body show as a black color or dark color. And we can get the this type of gray color. It show about the barren land. So it's a one kind of band combination near infrared red blue. Then I can get this type of feature, and I can easily identify for the vegetation, as well as the build up area, as well as also water body, and also barren land. I can easily identify about that. So now in this time, suppose I take the another band combination. Suppose I put at the short wave infrared one, then put at the near infrared, and then put at the blue, custom as 98%, and apply. So now I can get this type of band combination. I can easily find out the agricultural land, also vegetation. So in this time here you can see this type of gray color. Basically this type of color identify about the barren land. Okay, this it's a barren land. This type of color, yellow or grayish, this type of yellowish color identify about the barren land. Okay, and you can also get the water body this type of color. And now suppose cropland or vegetation, how I can define it. In this time, suppose here you can see also help of the satellite map view, then we can easily get it. In this time you can see this type of pixel. Suppose it's a green pixel but it's have a shape. It can be a square shape or rectangle shape. It's as a shape, then it will be considered as a agricultural land or cropland, not vegetation. In the agricultural land we must have a shape, or we can get the this type of rectangle shape, this type of shape. It will be shown. You can see this pixel we consider as the agricultural land. You can see agricultural land. And you can also these things, suppose you can simply decrease these things. We can easily find out this satellite view, Google satellite view, and we can easily get it. It's a one kind of agricultural land. You can see, okay, this type of shape, square shape, it's agricultural land. And when I open my satellite, suppose simply increase this thing, we can easily get it. It's the same. It's also agricultural land. So we can consider this type of pixel identify about that agricultural land.
Okay.
Okay, this type of is agricultural land.
Yeah, but sir, what I really want is I want like all these classifications. Can I get in like percentage area, like how much area
Yeah,
included
yeah. We also
in each
calculate the area
section?
also. No problem.
Yeah,
Okay.
because I need these values only. Yeah.
So you also calculate the also value.
Huh.
In this time, here I can get this type of things, as well as agricultural land. We can get this agricultural land, and for the, I think it's the agricultural land is a more in this.
Okay.
I think it also one kind of agricultural land. This type of picture.
Huh.
Okay.
Just 1 second, no? Just give me 1 second. Yeah.
Okay.
Yes, sir.
It also agricultural land. Yeah. Okay, in this time we can see we can get this type of forest. You can see what is the difference between the agricultural land and forest in the pixel. In this time we can get this type of unpattern. In this time there is no pattern. You can see it show this type of things. You can see it's there is no pattern. Okay, but agricultural land you can see the pixel. It have a pattern. Suppose a square shape or any kinds of specific shape. But in this time you can see it show this type of shape. You can see this type of thing unpatterned. Okay, so this type of things consider as a vegetation or forest. This type of things you can see also from here. You can see it show this type of things. It can be trees. You can see this type of shape also trees. Okay, also you can see it's not a agricultural land, it's just a trees or other. Yeah, so from here we can easily collect this training sample for crop, sorry, it's a forest or trees. This type of things we collect from here. Take this type of pixel, identify about the forest, not agricultural land, it's a forest or trees. And this type of yellowish color identify about the barren land. Okay, and this type of black color identify about that water body, it's a water body, water body. Okay, so in this time we find out all of those feature on the satellite images. So now we can collect the training sample. Okay, so how we can collect the training sample? For collecting the training sample, first of all you will just click on this marker tab, and then you can see geometry. Just click on here. Suppose I collect the training sample for water body, so just put here that water, and further just put here the feature collection and property. You can put any name as a property. I put the property name, suppose class. You can put any name and set the value for 0. Okay, and then okay. So now here you can see it selected the water body. It's a bold color when I selected, and then I use this marker and then collect the training sample for water.
Okay.
It's a water body. Just simply take the some sample of water body. And how much training sample you can got? Basically, it's depend on your accuracy. Okay, so after we can take more than suppose 50 first time, all of those sample, take the more than 15. But after checking my accuracy, if I don't get the better accuracy, then we also need to increasing about our training sample. Okay, suppose I can get the very low accuracy, less than 70 or less than 60. Okay, then we are also increasing the training sample more and run our model. So in this time also take the same training sample, so water body. So water body. Okay, like that. Water done. Further, simply click on the new layer and then click on the geometry and put this. Suppose in this time I take this for Berlin. And then further feature collection, property, put the property name as a class and set the value for 1. Okay, so first of all we put the all of those value 0 then 1. In this time for the barren land we can just take this type of things, this type of yellowish color. You can see it's a barren land, there is no vegetation, there is no water, just a fallow land. We just simply take that training sample from here. Fallow land. Fallow land. Suppose I take this type of training sample. Okay, after that take the new layer again. In this time we suppose we put that crop land or agricultural land. So crop land and put the feature collection and set that property is a class and set the value for this time 2. and then okay. So now in this tab we find out the pattern on our pixel. Okay, so basically you can see this type of pixel, and you can also consider you can see your satellite view of your image. We can get this type of area show as the agricultural land. You can see it's agricultural land. Okay? Then we are just simply open our satellite images. Also you can see, yeah, so in this type, yeah, so it's agricultural land. You can see this is about agricultural land. So just I simply put this training sample for crop plant. And crop plant we find out the pattern, this type of square or rectangle. This type of pattern is available only for the crop plant, but vegetation there is no pattern. So we take this type of pixel and first time we try to check, and after that in this time we take this training sample for vegetation. Set the feature collection property, set the property for class, and then in this time it will be 3. Basically, first of all we take the 0, then 1, then 2, and then 3. In this time we take the training sample for vegetation. You can see this type of things identify about the vegetation. Just
So, sir, when we do it like manually, these pointers, when we do, would it come like accurate for whole district?
this one.
Like how we are putting the pointers here for each class, like vegetation, then water bodies, then cropland. So would it come like accurately for the whole of the district? Like we have to select them manually.
Yes.
Okay.
In this time I take this training sample from here, but when I apply this model in the machine learning, it automatically predicted for the whole district or whole district in the Pune. It automatically predicts. Suppose I just take an sample from here, but this sample when the similar with the other pixel, it automatically predict it's a cropland, it's a vegetation, it's a water body.
Okay, okay. So we have to do for like few sample and then the
Yes.
rest will do it automatically.
Yes, yes.
Okay.
And when you any mistake, suppose just simply drag and delete, then it will delete it. Okay, we say take this type. Okay, so then finally we find out that mainly urban or build up. So just take the variable and put here. Yep. Their collection property. I set the property name suppose class and put here that it's a 4. And then okay. So in this time we try to find out that okay. In this time I simply I use here suppose. I think this reason is not must for the build up or settlement. Just I try to use the other band combination. Just try to add that near infrared and red and blue custom suppose 98%, and then apply. And try to find out the same white pixel. We get the one white pixel in here, so just simply increase and then show what is that. Okay, it's a build up. Yeah, it's a build up. Yeah. This time we consider it's a build up. So this white pixel, it's a build up. So just I simply collect the training sample from here. It will show the build up. Yeah, it also build up. You can see it show this type of white pixel. In this time, when I use this band combination, all of those this type of pixel identify about that build up. Okay, so it's also build up. I think what's it? Yeah, it also build up. You can see. Just simply now find out for other region. We can get some white pixel in here. I simply zoom it. So yeah, so it is a build up on settlement. We can find out. Just go here. We can get the some white pixel in here. So just a simple increase. Get from here, you can see it's a build up. Just from here, this pixel. We also get the some white pixel in here. So simply increase zoom. Yeah, you can give the build up. Now take also take from here. Also get the build up in here. You can see it's a build up. So now it's done. Okay. So in this time, suppose I take this type of training sample for you can see water, barrel land, cropland, vegetation, and build up. So now in this time, I need to make a data set. So for that, this data set I want to apply in the machine learning and make the land use land cover map. So for doing these things, first of all, I just take a variable, suppose sample. Okay. So I already collect the training sample. I take the variable suppose samples and then equal sign. I simply merge all of the training sample together one by one. So just call the water, then it hit merge with suppose Maryland, it merge with suppose Cropland, it merge with suppose vegetation, then merge with build up. Okay. So in this time, I just simply print that sample, then it show me all of those how many sample I collect for each all of classes. Okay. So click to the run. And I will save it this code because If you don't save it, then but you do all of those things, but some networking issue when you happen, then it will be destroy this link and we cannot find out this work again. Suppose I put this file name, simply save it. Okay, so now it will be saved in my asset skip tab. So further, if I you can see it will be saved. Okay, further I simply find out the script from here and then easily add in again. Okay, so in this time here I can get total 323 training sample, okay, for all of those classes. And in this time we are applying the supervised machine learning method. Okay, you know, basically machine learning, there are three kinds, popular, mainly supervised and unsupervised. In this time we are applying the supervised classification method and then find out the predict the other land use land cover area. So in this time we are applying the supervised, and supervised machine learning method must we take the training sample. Okay, we must need the training sample or pre-categorized data. In this time we are just make the pre-categorized data, mainly 323, and here you can see all of those data already pre-categorized. How I can identify that? Suppose 31, here you can see this property I set the 0. Okay, so this 31 training point I use to predict water, because I put the class name 0. Suppose I check the another training sample, suppose 82, I put the class 1, so it's a barren land. I use it, I use this training sample to predict the barren land. So all of those training sample I already pre-categorize or label. I set the label. Suppose I set the level 3, so this training sample I use for that vegetation. Okay, so I already pre-categorize. In this time I need to create a spectral signature. Mainly a spectral signature means that suppose this training sample, suppose this point I want to extract the spectral signature all of those bands values. Suppose in this time I make a list of all bands and I want to extract all of those band values. So basically every point have a different spectral signature. Suppose water have a unique spectral signature, vegetation have a unique spectral signature, or build up area have a unique spectral signature, and barren land have a unique spectral signature. Okay, so in this time we are just make a list of all bands. Suppose I just make a list, suppose take a variable, I put the variable name, suppose bands, and now I want to put all of those bands. So basically in this time I want to use this type of band which are okay, so I want to use suppose blue green and to use this type of band. I use this type of band. I simply copy from here, and if you want you are also input the some external band. So first of all you try to check this type of band. Suppose in this time blue green near infrared short wave infrared one, I want to extract all of those band values for each sample, each training point. Here I find out total you can see total training sample is that 323. So 323 all of points extract all of those band values and it create the data set. Okay, and a spectral signature is the unique for each classes. Then it easily, when I apply the machine learning, it easily predict the other area what happened. Suppose I just collect the water body from here, but when it find out the similar is a spectral signature, suppose this type of water has a similar spectral signature, it automatically predict it's a water body, it's a water body, it's a water body. Suppose I just take the cropland from here, but when this spectral is the similar with other pixel, it automatically predict it's a cropland. Suppose I just take this barren land from here or vegetation from here, but when this spectral signature is the similar with other pixel, it automatically predicts it's a vegetation or it's a forest. And it can easily predict for the other region. Okay. So in this time, I need to create the spectral signature or band values for each point. For that, I just take a variable. Suppose training, you can put any variable name. And then I want to extract the pixel. In this time, I want to extract the pixel from this satellite images. Which satellite image I want to use? In this time, I want to extract the pixel value for satellite image for year of 2015. I simply copy the 15 and call here, and then see, I paste here, and use the select function, select all of those band which is stored in the list. I simply paste here. Okay. Then use a function, this function called the so basically this function extract the pixel value in a collection. I already make the collection 323. So now I want to extract all of those bands pixel value from this collection. So just I put control, so I can get all of those argument. Just I fill up one by one. So just make the curly bracket start for dictionary and also curly bracket in for this dictionary. Okay. And then further just put here the collection mainly your sample, total sample 323. It is stored in a variable. This variable name is the samples. Simply copy the samples and paste here. Now properties. I already defined the property for all of classes. Here you can see this property name is the class. Okay, we have used the same property name. So class, and it's a properties. It's a plural form. So further we have to mention about that square bracket, and then put the property name. Scale is the resolution. Mainly it's a 30 meter. I put in here, and then remove all of those things. It's not need. So now we are just try to print this training and then check what happens. So print this training. Now it extract all of those band pixel value, for all of this point. Okay, you can see here it extract all of those band pixel value. Suppose this point, we can get total 7 properties. It's meant total 7 values. You can see blue, green, near infrared, red, short. So all of those values extract for this point. One, zero mainly one in this time. JavaScript it extract from the counting from 0, and class name is the 0. Class name is the water. So in this time, you can see I can got all of those pixel for each band for the water. Suppose I check the another, suppose click on here, you can see I also get this, all of those, it's called the spectral signature. Suppose all of those training sample extract the band information for each classes. Okay, so it's my data set. Okay, so in this time I train my model using this data set, and then further I just predict land use land cover classification using this model. Okay, so you can see it's my data set. So now this data set I want to use, and then further I just make the classification. You can see all of those training sample extract the band pixel, all of those training sample. So it's my data set. In this time, this data set I want to split into two way. Suppose some data set I want to use for train my model, and some data set I also use for check my validation about this model. What's the accuracy about this model? So after getting this data set I just need to split. Suppose in this time I use the 70% data to train my model, and suppose 30% data I want to use for check the validation. Okay, or if you want suppose 80% data to train your model, and 20% data you use for check your validation. Okay, so in this time it's my training. This variable is stored the full data set. This data set I want to randomly distribution 80% or 20% or 70%, 30%, anyone. So in this time I do it randomly. Okay, so for that, first of all I just take a variable. Suppose I put the variable name is that data set, and this data set training, basically it's training, it's all of those things. These things I want to do randomly distribution. So simply copy that and use the function random column. Okay, so basically this function randomly distributed my data and stored it in this variable data set. So further this data set I want to mainly split into two way, 70% and 30%. So in this time I just use here the train. Suppose I use here the 70% data, and for the testing I want to use here the suppose 30% data. Okay, so now I just take a variable. Suppose I put the variable name is that train set and call this data set, and then filter this data set at the equal. I take that random random 0.8. Okay, in this time we put it at that getter name, sorry, getter than 0.8. And further we take the another variable for test set, and call this data set. This data set we are just filter. How we can filter? Earth engine filter dot less than equal random 0. We fill this data set, and now this data set train set I want to use for train my model, and this data set I use for checking the validation, what the accuracy about this model. So let's go. In this time we have to create this model. For creating this model we have to use here different types of model. Machine learning model is available. So one very popular model is the random forest. In this time I talk about the random forest and use the random forest model and then make this land use land cover. So in this time I simply click on here and search here, suppose random forest. So here you can see all of those argument about this function. So this is the machine learning model. Basically in Google Earth Engine platform, this type of machine learning model is the built-in. Okay. So in this time here you can get the number of trees. In this time, this number of trees is very important for the accuracy. What's the value I want to put for the number of trees? So in this time, we don't know for this model what is the perfect number of trees. For that, we have to find out what's the number of trees is the best for my model to get the better accuracy. So it's called the hyperparameter tuning. So in this time, we need to find out the hyperparameter tuning, and this hyperparameter tuning give you the better accuracy. Okay. So in this time, I will just consider the random number and then find out the accuracy. Then we are just applying the hyperparameter tuning and then find out that best number of trees for our model. So I simply copy that. Simply copy these things and take a variable. Suppose I put the variable name is that model. I put this model in here and I put the number of trees, suppose 150. Okay, but I don't know what is the best number. Best number we have to calculate and put that later. In this time I randomly run my model and then check the accuracy what I can get, and then put here the train function. Put all of those things one by one. And further put 80% data and then would. Suppose I just simply make a curly bracket start. So curly bracket int, and then feature mainly your 80% data. 80% data mainly train set. I simply copy and paste here. Okay. Then class property mainly our property name, which is class. Input properties mainly band name. Basically this type of band, blue, green, near, and it already stored in a variable. This variable name is that bands. So simply copy the bands. Yes, sir. Okay. So it's not it. You get on it. So now I want to just try to print this model, and I can get all of those things about my model. Okay, here you can see the result. You can see classifier train. In this time here we can get this type of information, mainly feature. We can get this type of randomly class property is the class. We are put here this algorithm, and in this time number of trees I put here the 150. Importance mainly in this time we are just use this type of uh, importance as a band value. We just is here, and when I put here the suppose explain, then it's also better we can get the tree. So explain this model. So now we can get the details in the sum total 5 properties in here. These are classes 0, 1, 2, 3, 4. 0 is the water, 1 is the barrel land, then cropland, then vegetation and build up. And importance mainly 6 properties. In this time it's our band blue, green, fire, short. Okay. In this time number of trees, and you can see it is our out of bug error estimate 0.017. And trees, you can see it create the 150 trees. Okay, so basically in the random forest it create the in this time in my model it create the 150 trees because I mentioned here that 150. And what is the trees mainly? You can see the random forest algorithm. Suppose I just show you that random. Okay, so just like search here random forest. Okay. Basically you can see here it's one kind of random forest simplified model. So here you can see the it's a tree, so it's create the one tree, it's another tree, and the dot 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 and in tree. Okay, so it's a lot of trees. So in this time this tree number I put here 150. Okay, so that's why in this time in my model create the 150 tree for each classes, and from here it find out the majority voting. Suppose 150 in this time example for the 3 trees. Suppose one tree I can get the vegetation, for the second tree I can get the vegetation, third tree I can get the suppose water. So now it consider the majority voting. Majority I can get the vegetation, so that's why it selected the vegetation in final class. So in this time when I put here the 150, let me save it. In this time when I put it the 150, it create the 150 trees. You can see between all of those band use and create the 150 trees. You can see blue less than equal 0.9, green near infrared. So it is a use the different types of mainly condition and identify the different types of classes. So it's basically it's the one kind of trees. And how many trees is create? It's create the 150 trees, and then find out the majority voting, and then predict the land use landmark classification for other region. It's total show you the result for 149 mainly 150 because it's set from the 0. Okay, so it's a 150 trees it create for. And how it create this condition? Mainly this condition depends on our input. In this time which input I put, in this time I input the blue, near infrared, short infrared, this type of things. So it create the trees according to this condition, different of condition. So this is my model. So now this model I want to use, and further I also need to check make the land use land cover classification and also make the accuracy. Okay, okay, so in this time we are just make a break for the 5 minutes. After that we'll join again and then continue. Okay, for the 5 minutes we'll start. Okay, okay.